In the heart of Silicon Valley, a revolution was brewing. In 1968, Robert Noyce and Gordon Moore, two pioneers of the semiconductor industry, founded Intel. Their vision was simple but ambitious, to build semiconductor devices that would change the world. In 1971, Intel unveiled the 4004, the world's first commercial microprocessor. This tiny chip, a marvel of engineering, packed the power of a room-sized computer onto a single piece of silicon. The 4004 was a watershed moment in computing history. It marked the birth of the personal computer era. Intel's invention democratized computing power, making it accessible to millions around the globe. The x86 architecture introduced in 1978 further cemented Intel's dominance. This architecture became the industry standard, powering generations of personal computers. Intel's microprocessors became ubiquitous, found in everything from desktop PCs to servers. The company's iconic Intel Inside logo became synonymous with quality and performance. Intel's innovations fueled the digital revolution, enabling the creation of countless software applications and hardware devices. The impact of Intel's early inventions cannot be overstated. They transformed the way we live, work, and communicate. The world was entering a new era, and Intel was at the forefront of this technological revolution. Throughout the 1980s and 1990s, Intel's star continued to rise. The company rode the wave of the PC revolution, becoming a household name. Intel's processors powered the machines that brought the internet to homes and offices worldwide. With each successive generation of processors, Intel pushed the boundaries of performance and capability. The Pentium processor, launched in 1993, was a major milestone. This chip brought powerful graphics and multimedia capabilities to personal computers. The Pentium brand became synonymous with high performance, propelling Intel to new heights of market dominance. Intel invested heavily in research and development, constantly innovating and refining its products. The company's manufacturing prowess was unmatched, allowing it to produce chips at scale and with incredible precision. Intel's fabs, massive factories where chips are made, became wonders of modern engineering. As the internet boom gained momentum in the late 1990s, Intel's processors were at the heart of the infrastructure. Intel's server chips powered the data centers that hosted websites, email, and other online services. Intel became an indispensable part of the digital economy, its chips powering the servers that processed trillions of dollars in financial transactions and connected billions of people online. As the new millennium dawned, the tech landscape began to shift. The rise of mobile devices such as smartphones and tablets presented a new challenge for Intel. These devices required energy-efficient chips, a market where Intel was slow to adapt. Competitors like ARM emerged, offering low-power processors that were well-suited for mobile devices. ARM's architecture, based on a licensing model, allowed other companies to design and manufacture their own chips. This approach led to a proliferation of ARM-based processors in smartphones and other mobile devices. Intel's x86 architecture, while powerful, was not as energy efficient, putting the company at a disadvantage in the rapidly growing mobile market. At the same time, AMD, Intel's longtime rival in the PC market, began to regain ground. AMD's Ryzen processors, launched in 2017, offered competitive performance at lower prices, eroding Intel's market share. AMD's success was due in part to its partnership with TSMC, a Taiwanese semiconductor foundry. TSMC's advanced manufacturing capabilities allowed AMD to produce chips with smaller transistors, leading to improved performance and efficiency. Intel's dominance in the semiconductor industry was built on its mastery of manufacturing. The company's ability to shrink transistors, the tiny switches that make up a chip, allowed it to pack more performance into smaller spaces. This relentless pursuit of Moore's law, the observation that the number of transistors on a chip doubles approximately every 2 years, had been the engine of Intel's success for decades. However, as transistors approached atomic scales, shrinking them further became increasingly difficult and expensive. Intel stumbled in its transition to smaller process nodes, particularly its 10 nanometer and 7 nanometer processes. These delays allowed competitors like TSMC and Samsung to take the lead in manufacturing technology. TSMC in particular became the foundry of choice for companies like Apple, Qualcomm, and AMD, all of whom were designing chips for the booming mobile market. Intel's manufacturing woes were compounded by internal missteps. The company's decision to stick with its own manufacturing facilities, rather than outsourcing production to foundries like TSMC, proved costly. Intel's fabs, while state-of-the-art, were optimized for its own designs and struggled to adapt to the needs of other companies. The consequences of Intel's missteps were felt throughout the company. In 2024, Intel reported its first annual loss in over 3 decades. The company's stock price plummeted, wiping out billions of dollars in market value. Investors, once bullish on Intel's prospects, began to question the company's future. Intel's financial troubles were a stark reminder of the challenges facing the semiconductor industry. The days of easy growth were over. Competition was fierce, manufacturing costs were soaring, and the global economy was slowing. Intel, once the undisputed leader, was now fighting to stay afloat. In an effort to stem the bleeding, Intel announced a series of cost-cutting measures. The company slashed its dividend, laid off thousands of employees, and put several projects on hold. These moves were painful but necessary, as Intel sought to conserve cash and refocus its efforts. Section 6: Navigating Troubled Waters. Faced with mounting losses and a shrinking market share, Intel's leadership knew that drastic action was needed. Pat Gelsinger, who took over as CEO in 2021, embarked on an ambitious turnaround plan. Gelsinger, an Intel veteran who had left the company in 2009, brought a renewed sense of urgency and a deep understanding of the industry. Gelsinger's plan, dubbed IDM 2.0, aimed to revitalize Intel's manufacturing operations and regain its technology leadership. The plan called for massive investments in new fabs, both in the United States and abroad. Gelsinger also announced plans to open up Intel's manufacturing facilities to outside customers, a major shift for a company that had long prized its independence. Intel's decision to become a foundry was a bold move, one that carried significant risks. The company would need to compete with established players like TSMC and Samsung, both of whom had a head start in the market. However, Gelsinger believed that Intel's manufacturing expertise and its commitment to innovation would give it a competitive edge. Section 7: IDM 2.0 – A Bold Strategy. Central to Intel's turnaround strategy was its IDM 2.0 initiative. IDM stands for Integrated Device Manufacturer, a model where a company designs and manufactures its own chips. Intel had long been a champion of the IDM model, but with IDM 2.0, the company was taking a more nuanced approach. IDM 2.0 recognized that Intel could no longer go it alone in the highly competitive semiconductor industry. The company would need to partner with other companies, including competitors, to share costs and accelerate innovation. This meant embracing a more open ecosystem, one where Intel would both design and manufacture chips, as well as manufacture chips designed by others. A key element of IDM 2.0 was the creation of Intel Foundry Services, or IFS, a standalone business unit dedicated to providing foundry services to external customers. IFS would leverage Intel's manufacturing expertise and its vast intellectual property portfolio to attract customers looking for a reliable and technologically advanced manufacturing partner. To support its ambitious plans, Intel sought government support. The company lobbied heavily for the passage of the CHIPS and Science Act, legislation that would provide billions of dollars in funding for semiconductor research and manufacturing in the United States. The CHIPS Act, signed into law in 2022, was seen as a major victory for Intel and the broader U.S. semiconductor industry. It provided a much-needed boost to domestic chip production, which had declined in recent decades. Section 8: The Future of Compute. As Intel navigated these challenges, the company also looked to the future. Intel recognized that the world of computing was evolving rapidly. The rise of artificial intelligence, the explosion of data, and the growing demand for immersive experiences were creating new opportunities. Intel invested heavily in AI, developing specialized chips and software optimized for machine learning workloads. The company's Xeon scalable processors became the workhorse of data centers, powering AI applications ranging from image recognition to natural language processing. Intel also made strides in graphics processing units, or GPUs, a market long dominated by NVIDIA. Intel's Arc GPUs, launched in 2022, aimed to challenge NVIDIA's dominance in gaming, content creation, and AI. These GPUs leveraged Intel's expertise in chip design and manufacturing to deliver high performance and efficiency. Intel also explored new frontiers in computing, such as quantum computing. Quantum computers, which harness the principles of quantum mechanics, have the potential to revolutionize fields like medicine, material science, and artificial intelligence. Section 9. A Pivotal Crossroads. As Intel entered the second half of the 2020s, the company stood at a pivotal crossroads. The decisions made in the coming years would determine whether Intel could regain its former glory or fade into irrelevance. Gelsinger's turnaround plan was ambitious but risky. It required massive investments, flawless execution, and a bit of luck. The stakes were high for Intel, its investors, and the US technology industry as a whole. Intel's success was crucial to maintaining America's leadership in semiconductor technology. The company's chips powered everything from smartphones and laptops to data centers and military equipment. A weakened Intel would have ripple effects throughout the global economy. The world was watching to see if Intel could pull off a remarkable comeback. The company had a long and storied history of innovation and resilience, but the challenges it faced were unprecedented. Only time would tell if Intel could recapture its position as the undisputed leader of the semiconductor industry.